Okay, we're going to do this problem. Our goal is to find the equation of the ellipse. We're going to find the major axes, the minor axes, the area, the perimeter, eccentricity, and the lattice R. Here we go. Okay, it's not going to be that bad. Just takes a minute. Okay, so step one, let's move some stuff around. When they do this, they're really trying to just to be mean to you. Okay, you want to make this look more like we want to do the math here. So 4x squared. Let's see here. I'm going to keep that minus 8x right here. Let's see. I think I'm going to put plus 9y squared plus 126y. I'm going to add 131 over. Okay, does that make sense? I'm now going to start grouping. I look at this right here, and this scares me a little bit because I know that's one more step I have to be concerned with. But when I start doing this out, I factor out 4. It gives me x squared minus 2x, correct? Factor out a 9. That gives me a y squared plus 14. And that equals 131. Let's take another look. Okay. Now, when I start doing this out, it's a double completing the square problem. If you're not familiar with that, I'm sure there's another video. But you know, we'll just get through it for now. Half of negative 2 is negative 1. Negative 1 squared is 1. And I'm going to add 1 to both sides, but that 1 is really being multiplied by 4 here. So the trick is, I'm adding 4 to this side. Okay, now that's the trick that gets every one of this stuff. Make sense? Now, half of 14 is 7. 7 squared is 49. So when I add 49 here, I'm really adding 9 times 49 to the other side, and that is 441, I think. I'm going to add all those together, and I think that gives me a 576. Okay? Oh, sorry, there we go. Now I'm going to take this quantity here, I'm going to make that into a binomial squared. That's kind of the whole process of why we did it, right? Or the whole point of why we did it. X, take that sign, square root of your c value. There we go. Plus 9 times y, take that sign, square root of your c value. There you go. And now the intent is to get it equal to 1. So if I'm going to divide both sides by 576, I'm now just going to divide out these, and hopefully that simplifies. So 4 over 576, I believe, reduces to 144. I believe 9 over 576 reduces to 64. And that is equal to 1. Okay? So there are a couple different things we have to realize. Again, I might be overstating some assumed knowledge, but we know that this is going to have major vertical axes. We know this is a result of 12 squared, making that our A value. This right here is the result of 8 squared. That'd be my B value. Okay? We're also noticing, when I look at this real quick, this is not centered at the origin. This is a shift. Okay? This is a slide. It moved around. Okay? So I know immediately that my new center is going to be 1, negative 7. Opposite, right? So if I have my new center is equal to 1, negative 7, that is some good stuff to know. I know that it's going to be, well, here, let me start graphing it and I can describe better. Okay, hold on. Let's see here. So 1, negative 7, 1, negative 7, I put a dot. Okay? Now, I know that my horizontal shift is 12 in either direction from there. So if I started here at 1, I'm going to move to 13. Right? And I'm going to move on this side to negative 11, I believe, right? 6, 7, 8. I'm not doing it perfect, but you get the idea. And I know my vertical shift is going to be 8 above, 8 below that. So if I'm at negative 7, I'm going to be up here, and I'm going to be down here. Okay? So let me draw this out real quick. This is not obviously perfect. This is not good at all, but you get the idea. That's going to be the ellipse right there. Okay, so I actually have all the information I need to find the rest of the stuff I want. Okay, again, that's the equation that I'm looking for. I got the center, and we're going to go from there. Okay, so from here, what do I want to find out? Well, the first thing I'm going to clearly identify here is my minor axes. Okay, sometimes it might ask you to find the covertices. Well, the covertices would be right here in the end of the minor axes. The major axis, I missed it a little bit, but right there. These would be your vertices. Okay, vertices on the end of the major axis. Now, I'm going to have to find something called the focus. I'm going to find something called, it's kind of a funny name, I guess, but a lattice rectum. I'm going to call it my lattice R so I can keep a straight face myself. I apologize for that. Oh, that's where I was drawing it. And I also want my eccentricity. And what that basically is a value that kind of gives us a baseline of how close it approaches zero. I'm sorry, yeah, well, I'll say it another way. If that value is 0, it's going to be a circle. As it approaches a higher value, up to 1, it's going to change to different things. Higher the number, it might change to a parabola or a hyperbola or eventually a straight line. But typically, we're going to be looking from greater than 0, less than 1 for a value. Okay, and I'll explain how to do all those things. Our major axes are pretty obvious, but I'll write it down, and our minor. Okay, here we go. So let's go for the easy ones. Our major axes are going to be all the way across where it's the major axes. So I know that's going to be what, 12 and 12 is 24. 24 units, whatever that may be. Again, because that's 12 units across that whole place. And then my minor is going to be 16. Obviously the 8 and the 8. Okay, the center again we indicated was 1, -7. Okay. So, I am going to say a new word here, a focus. If we're talking about plural, we call them foci, but this will be a point, right about, oh, that doesn't work very well. A point roughly there. I'm not making that point in a reference, just let's say about, okay? We can actually find out in a minute, but we're not caring right now. But basically, we're going to find that value. And one way to do it, or probably the way, is to take this value right here, and drop down to that focus and extend that line over. Now we know this is 12, and actually this line will be 12. What we don't know now though is the distance from here to here. We're going to call that our C value. We're going to call that our A value. We're going to call this our B value. Okay? Now a couple things we're going to do. If you're thinking about it and you're correct, that is a 90-degree angle. Okay? And what I want to find is right now the C value. I have my A and my B. So you're right if you're thinking Pythagorean theorem. That's all it is. So 12 squared is 144. 8 squared is 64. And I get the square root of that value essentially, right? So I get, what's that, 0, 8, root 80. And root 80 is root 16, root 5. And that's going to be a 4 root 5. So my C value is 4 root 5. So if I'm looking for my value here, for my focus, let's see, I'm already at 1 unit over, so it looks like I'd be at 1 plus 4 root 5. And that's how I'd get that value if I asked for the vertices, which I didn't this time, but that's all you have to think about to get that. Okay, so we found the distance to the focus there. That was easy. Okay. We're now going to find my LR, my lattice R, and that's going to be defined by 2b squared over a. Okay, 2b squared over a, and that is going to be how I find that value right there. Now, if you're curious what that value really is, I'll draw it on this side, there's less writing. It's going to be perpendicular to that focus and one part of the major axes. Okay, it's just another value that's going to be used for different things later on, and that's just where we're going to find it right now. Okay, so obviously 2 is fairly self-explanatory. B, well in this case, B was 8 squared, and all over A, and A being, what's that, 12? Well, 8 squared is 64, times 2 is 128, so I get 128 twelfths. Well, 128 twelfths, let's see, that's 64 over 6, and that's 32 thirds. So lattice R is 32 thirds, and again, that's the length of this value right here. Okay? Eccentricity, again, we talked about how That's just going to be a value that has different meanings later on, especially in physics type applications. But for right now, we're just going to find the math. And eccentricity is determined by your ratio of c divided by a. Okay? Well, if I have c divided by a, I have 4 root 5 for my c over 12. Well, right here, if I have 4 root 5 divided by 12, that gives me root 5 thirds. And there we go, root 5 thirds. Okay? Now, 2 more values I'm going to ask you. I'm going to say, what's the perimeter? What's the area? Now, the area, I just want to give you the concept, so hopefully it's an easier thing if we think about it. So let's go back to a circle. Very friendly to an ellipse here, a similar type thing. Let's say that's radius. I bet you're familiar with area equals pi radius squared. Well, what that's really saying is if we have 2 radii, but they're the same, it is pi times radius times radius. Does that make sense? Now, in the case of a circle, which is a special form of an ellipse, the radiuses are the same, or the radii is the same, correct? So r times r is r squared, and we get pi radius squared equals area. Well, a very similar thing occurs in an ellipse. I'm not going to call them radii, but we're going to get the idea. Let's call this, I don't know how you want to call it. Let's just call this your a value and your b value for lack of a better thing right now. Why don't we say b times a, or a times b, times pi would be your portion of a radius, and no different than how you found the area of a circle. It's going to work that easy. So it's going to be pi AB or pi BA, doesn't really matter. So in this case, it's going to be, what did we have? We had a 12, and we have 8, and what's that give me? 96. So 96 pi would be your area of that ellipse. Okay? Now, perimeter is a much worse thing with ellipses. There's actually a bunch of possibilities. This is the easiest of all of them, and it's going to give you a rough approximation, nothing perfect, but, you know, I guess how many times do you really need the exact perimeter of an ellipse? And if you need it in that application, I'm sure someone would help you go through the steps to find a more exact value. But for right now, it's just going to be 2 pi times the square root of a squared plus b squared over 2, making sure that you remember that radical encompasses the 2 in the denominator. Okay, so if we do a squared in this case, we get 12 squared is 144, plus b squared, I think it's 64, and that gives me 8, what, 208 divided by 2 is 104. Well, if I have 104, and I take the square root of that, I don't remember what it was. Just give me 1 second. So either way, it's going to be 2 pi root 104. Which is probably fine for right now. Actually, you don't care. Neither do I. But this can be an exact answer. So again, let me check again. So I have 12 squared, 144, plus 8 squared is 64, 8, 10, 208 divided by 2, 104. Yeah, whatever that decimal approximation be, 2 pi root 104 would be your approximate perimeter. Now, there are some restrictions on that. I want to say, and it could be, don't quote me here, I want to say if like the longest portion is at least less than 3 times the length of this one. There are a few restrictions, but for most purposes, this is the easiest way to find the perimeter. Approximation of. Okay, that was not that bad, huh? Math is fun. Good job.